Welcome to Geometry Chapter 1, Lesson 3. We're going to use the midpoint and distance formulas. There is an activity here about folding a segment bisector, which you can do. We actually did this in class. So let's go through our definitions. The midpoint of a segment is the point that divides the segment into two congruent segments. A segment bisector is a point, ray, line, or line segment or plane that intersects the segment at its midpoint. A midpoint or a segment bisector bisects a segment. And you want to remember that bisect means cut it into two equal parts. So as I talked about yesterday, this mark and this mark show that A to M and M to B are congruent. This line, CD, is going through point M, so it is actually a line bisector. Okay, we'll call it a segment bisector, but a segment bisector is actually a name that would work for a point, ray, line, segment, or plane. So first, let's go through some warm-up activities. Find a point between -3, 5, and 7, 5. I want to change that and put midpoint because there are actually lots of points between -3, 5 and 7, 5. If you think about this, although you don't need to draw a picture, -3, 5 is going to be over here in quadrant 1. -3, 5 is going to be over here in quadrant 2. 7, 5 is going to be over in quadrant 1. The y value isn't changing, so I'm going from -3 to 7, which is a distance of 10. Okay? So we want the midpoint of that is what I want. Now, they actually said any point, so anything that has an x value of greater than -3 and less than 7, but with a y value of 5 would be in between. Find the average of -11 and 5. From -11 to 5, if I add those together, actually just take the average, -11 plus 5 is -6, and -6 divided by 2 is -3. Solve this. So we have to remember that first, instead of dividing this side by 2, we multiply both sides by 2 to get rid of the division of 2. So x plus 7 equals 10. I subtract 7 from both sides. X equals 3. For the square root of 30 to the nearest hundredth, you're going to use a calculator. You're going to put in the number 30, then the radical symbol or the square root symbol, and round to 5.48. And if we round the square root of 5 plus the square root of 20, in the calculator you actually find the square root of 5, then you actually find the square root of 20, you add them together, and you get 6.71. In example 1, we're going to find segment lengths, and we're going to talk again about the idea that a bisector divides something into two. So this line segment, VW, actually bisects XY at point T. Bisect means break it into congruent parts. So that means that it's kind of hard to see these numbers, these letters here. X, that was Y. So XT plus TY is equal to the entire length. If XT equals 39.9 and XT is equal to TY, then TY has to also equal 39.9. So 39.9 plus 39.9, or you could do 39.9 times 2, is 79.8. That's the total length. In example 2, you can also use algebra. Point M is the midpoint of VW. So find the length of VM. That means that VM is congruent to MW. So 4x minus 1 is congruent to 3x plus 3. And so we subtract 3x from both sides. We get x minus 1 equals 3. We add 1 to both sides. X equals 4. So if x equals 4, and we want to find VM, our answer isn't 4. 4 times 4 is 16, minus 1 is 15. And we can check that that works by making sure that MW, we get that same answer of 15. 3 times 4 is 12, plus 3 is 15. So each of these segments is 15. If I were to add them together, the entire VW would be 30. But I am asked to find the length of VM. And that takes you through the rest of the work that I just did. So we're now going to do guided practice for examples 1 and 2. In exercise 1 and 2, identify the segment bisector of PQ. So the segment bisector is being bisected by MN, which is a ray. Okay? And also, if PM is 1 7/8, MQ is 1 7/8. So 1 7/8 plus 1 7/8 is 3 3/4. Now we could also use algebra. The segment bisector is line L. I actually shouldn't have made that L cursive unless I was going to write the whole thing cursive, so I'll write the whole thing cursive. Line, very bad handwriting, L. That means that 5x minus 7 is going to be equal to 11 minus 2x. I'm going to add 2x to both sides. I get 7x minus 7 equals 11. Now I'm going to add 7 to both sides. I get 7x equals 18. And I get x equals 18 sevenths. I then want to find the length of the entire PQ. So now that I found out that x is equal to 18 sevenths, this is getting a little messy, but I can deal with it. I'm going to erase this part over here. And I'm going to use, find PQ. So I need to find one side and then multiply it by 2. I'm going to use 11 minus 2x. So 11 minus 18 times 2 is 36 over 7. 7 goes into 36 5 times with 1/7 left over. So 11 minus 5 would be 6, but I also need to subtract 1/7. So that's 5 6/7 is one side. 5 6/7 plus 5 6/7 is 10 12 sevenths. So 7 goes into 12 one time with 5 left over. So 10 plus 1 5/7 is 11 5/7. Line L is the bisector. 11 5/7 is the total length of the segment. So now we are going to get to the midpoint formula. Yesterday, we were finding segment lengths on a coordinate grid that were either horizontal lines, segments, or vertical line segments. Since there was no change in y values or x values, we could count the spaces. Now you can see that we are getting into lines that go at a diagonal. So there's a formula that you can use, and I talked about this in class yesterday, but I didn't show you the formula. So basically, if I have two coordinates, I'm going to first take the x values of the two coordinates, add them together, and divide by 2. That's the average. And you'll remember in the warm-up we talked about finding an average. And then I'm going to do the same thing with the y coordinates. I'm going to take the values of the y coordinates of the two endpoints of the line segment, add them together, and divide by 2. Let's look at how this actually works. So in example 3, to find the midpoint of RS, I'm first going to take the x coordinates, which are 1 and 4. I'm going to add them together to get 5, and then I'm going to divide in half. So that's 2.5, which makes sense. Looking here, it looks like that's going to be about 2.5. And then for my s values, not for my s values, for my y values, -3 plus 2 is -1. -1 divided in half is -0.5. So those are my coordinates. This takes you through that math. They put 5 halves. Now that we're in geometry, we're going to go back to decimals. So if you put 5 halves, that's fine, but I put 2.5, as I said, and -0.5. Now we're going to find an endpoint. So the midpoint of JK is 2, 1. One of the endpoints is 1, 4. So let's think about what we're doing here. We're going to have 1. We're going to add some number to it. I'm going to call that x. We're going to divide by 2. We're going to have 4. We're going to add some number y to it, and we're going to divide by 2. So over here, I want to take 1, add some number, divide by 2, and get 2. So once I divide by 2 to get 2, I needed to have 4. So 1 plus what number is 4? 1 plus 3 is 4. Same thing over here. I'm going to take 4. I'm going to add some number, I'm going to divide by 2, and I'm going to end up with 1. So 2 times 1 is 2. 4 plus what number equals 2? Actually, 4 plus -2. And you can actually see here that they've graphed this. At this point is 3, -2. That is the endpoint. So I've done my math correctly. This walks you through the step. And you'll remember that in the warm-up, we had problems that looked like that. That's why they give us the warm-up they give us. So let's try 2 of these. You can freeze this video and try it. But the endpoints of A, B, so these are the endpoints. I'm going to take the x values, 1 and 7, I'm going to add them together, which gives me 8. Then I'm going to divide by 2, and I get 4. For the y values, I'm going to take the y values 2 and 8. I'm going to add them together to get 10. Then I'm going to divide in half, and I get 5. So the midpoint of segment AB is 4, 5. Now, I'm given the midpoint and 1 endpoint. So I'm going to start at 4, 4. And once I get to -1, -2, I'm halfway there. Okay? So I want a number. I'm going to do 4 plus some number divided by 2. And I'm going to do 4 plus some number y divided by 2. When I do 4 plus some number divided by 2, I want negative 1. So working that backwards, times 2 is negative 2. So 4 plus what number gives me negative 2? 4 plus negative 6 gives me negative 2. And then for the other thing, I'm going to take 4 plus some number divided by 2 and get negative 2. So negative 2 times 2 is negative 4. 4 plus negative 8 is negative 4. So that was my answer. Negative 6, negative 8. So now we're going to go through the distance formula. So the formula I went through briefly in class yesterday. Basically, it is the change in the x values squared plus the change in the y values squared of the two endpoints, and then the square root of it. It is a variation of the Pythagorean theorem because a squared is the length of one side of the right triangle. You can see that here. From here to here, we kind of graphed out a right triangle. So the length of A squared plus the length of B squared equals C squared. We take the square root of that and we get the length. You do not need to understand all of that, but it is an enrichment idea in this lesson, the relationship between the distance formula and the Pythagorean theorem. And speaking of that, I'm just going to show you that here, what we're talking about. So to get from S and R, we can travel in a diagonal line. We can also kind of make some dashed lines here and make a right triangle. This side here is 2. 2 squared is 4. This side here, 1, 2, 1, 2, 3, 4 is 4. 4 squared is 16. 4 plus 16 is 20. So that would mean C squared, this angled here, is 20. So C equals the square root of 20. And 20 square root is 4.47. That's closest here to 4.5. This takes you doing it with the distance formula, which I'm going to use from now on. I just wanted you, some of you will get the correlation between the distance formula and the Pythagorean theorem. Now, we also talked about this in class yesterday. Does it matter which ordered pair you choose to substitute? No, it does not. You'll get the same answer as long as you decide which ordered pair is pair 1 and which ordered pair is pair 2. So what is the approximate length of AB? I'm not going to use Pythagorean theorem. I am going to use the distance formula. They write it as x sub 2 minus x sub 1 quantity squared plus y2 minus y1 quantity squared. I'm still going to just do them in this order. So negative 3 minus 1 is negative 4, and negative 4 squared is 16. 2 minus negative 4 is the same as 2 plus 4, which is 6. 6 squared is 36. So 16 plus 36 is 52, and the square root of 52 is 7.2 to the nearest tenth. So the correct answer is B. And now it's time, we've done all the types of problems for our daily homework quiz. So A, B bisects CD. So I'm going to make this C, I'm going to make this D, This is line segment AB. If it bisects, then that means that C to A and A to D, sorry, it bisects at E. I didn't break that. And C to A. C to E is congruent to E to D. So if C to E equals 2 1/4, that's 2 1/4 here, plus 2 1/4 here, makes 4.5, or 4 1/2. If M is the midpoint of XY, find XM. That means that 2x plus 7 is going to be equal to 8x minus 23. We're using equal because we're dealing with numbers. We would say that XM is congruent to MY. So I'm going to subtract 2x from both sides. I get 7 equals 6x minus 23. I'm going to add 23 to both sides. I get 30 equals 6x. So x equals 5. But I don't want the value of x. I want the length of xm. So I'm going to substitute 5 back in for x. 2 times 5 is 10. Plus 7 is 17. If I wanted to check my work, 8 times 5 is 40, and 40 minus 23 is 17. So I know that they both work. So point M is the midpoint of PQ. These are the endpoints. I want to find the coordinates. To find the midpoint, I'm going to take the average of the x coordinates of the endpoints and the average of the y coordinates of the endpoints. So for the x coordinates, 2 plus -8 is -6. -6 divided by 2, because I want the average, is -3. For the y coordinates, -6 plus 0 is -6. -6 divided in half for the average is -3. So the answers are -3, -3. Now for the midpoint of GH, and I'm going to take a little more time here in case you're still not quite understanding this. So one of the endpoints is 5, 3. We want to find the coordinates of the other endpoint. But we know that the midpoint is 4, -1. So for the x coordinate, I'm going to take 5. I'm going to add some value for x. I'm going to divide by 2, and I want to get 4. I'm going to do the same thing for the y values. 3 plus some number y divided by 2 is -1. So let me set this up here. 5 plus x divided by 2 is going to be 4. This is what I've been saying before. I multiply both sides by 2. 5 plus x equals 8. And I know that 5 plus 3 equals 8. Now for the other one. 3 plus y divided by 2 is -1. I multiply 2 by both sides. I get 3 plus y equals -2. If I subtract 3 from both sides, I get y equals -5. So now I have the coordinates of the endpoint when given one endpoint and the midpoint. And our last problem here on the daily homework quiz is a word problem. Darren wants to find the distance between a swing and a sandbox. He doesn't just have a ruler, so he makes a graph and found the coordinates of the swing to be 7, 2, and the coordinates of the sandbox to be 3, 8. x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. So I'm going to write this over here. 7 minus -3, that's the same as adding. 7 plus 3 is 10. And 10 squared is 100. plus 2 minus 8 is negative 6. And negative 6 squared is 36. So 100 plus 36 is 136. Quantity squared, I don't know the square. It's not quantity squared. The square root of 136 is that number, which rounds to the nearest tenth to 11.7. And then here are the problems that your homework.